The modern theory of subduction zones fails to answer the following simple questions. Question 1. How can an oceanic plate with a density ranging from 2.8 to 3.2 grams per cubic centimeters sink deep into the mantle, the density of which ranges from 3.6 to 4.6 grams per cubic centimeters? In other words, the density of the mantle, even in its upper layers, is almost twice as high as the density of the crust. Therefore, plates cannot sink into the mantle under their own weight, even to shallow depth. This is impossible due to the laws of physics, and it's all the more impossible because the rocks inside the mantle are under enormous pressure that increases with depths. It's like trying to push a cracker into a piece of thick rubber, like a tire. How can a plate go into the mantle like a knife into butter without experiencing any resistance from it? This is absolutely impossible. Question 2. The speed of plate movement ranges from approximately 2 to 12 centimeters per year, and the temperature in the upper mantle averages 1200 degrees Celsius. Attention! How can the plate at such a slow speed not melt inside the mantle over such a long period, and not shatter into small pieces under such pressure? Because their theory suggests that the plates sink into depths of 700 kilometers, which would take hundreds of millions of years. Question 3. The plates are believed to subduct into the mantle at angles between 30 degrees and 90 degrees. I mean, according to this theory, the plate would be bent at these angles. However, a plate cannot withstand even minor bending without deformation. Look, the entire ocean floor is covered with fractures, indicating the brittleness of the plate. Therefore, during subduction, series of cracks tens of kilometers wide should have appeared. Where are they? These cracks have not been found in the subduction zone areas. Question 4. Every layer inside the Earth is moving. There is plate motion, mantle motion, and core motion. The core in particular rotates faster than all other layers of the Earth. There is a regularity. The further a layer is from the core, the slower its movement speed. As you already know, plates move at a rate of 2 to 12 centimeters per year. The mantle, which is closer to the core, moves faster than the Earth's crust. This means that any end of the plate, for whatever reason submerged into the mantle, would be torn off by the mantle's flow. But it doesn't break off, because it's just not there. Question 5. The lengths of mid-ocean ridges where the crust is accreted significantly exceeds the lengths of subduction zones, where excess plate material supposedly crawls in. So what does this imply? More crust accretes than crawls into the subduction zones? There are many more similar inconsistencies and unanswered questions. Moreover, 60 years ago, scientists perfectly understood that the subduction theory and lithospheric plate tectonics in general were entirely